Cool. All right. Sorry for the delays. Thank you again for coming to another discussion hour series. We will hear from two people today. I'm trying to minimize this so that I can go away. Please. Perfect. Yeah, first we'll hear from Malcolm coming from the BEG to discuss a very interesting project going on with geothermal opportunities to collaborate. So yeah, reach out to Malcolm after this if you'd like to hear, and then after we'll hear from Sara about projects here at UTIG. So thank you, Malcolm.
Yes. So a little background on me. I am actually a UT grad, a UTIG grad. I did a master's here, 84 to 87. PhD with Pete Vale in sequence stratigraphy at Rice. And I had a variety of jobs, gotten out of geology. I spent 13 years at Shell, where I ended up as a subject matter expert for geothermal energy. And I've been doing a lot of consulting. I call myself a geothermal evangelist for the last 3 years, I guess. And part of that evangelism is taking place today as we speak. There is one wrinkle in my resume that I should explain. I had a double major as an undergraduate in geology and theater. So my focus was Shakespeare, so I'm going to do this in iambic pentameter. Was Shakespeare and improv. In improv, I find giving presentations and lectures a form of improv. So I need you to interact with me. That's part of what improv is. And so I expect you to interrupt me as we go along. This is a discussion group, so please interrupt me. You will not be knocking me off the script. I will feed off of your energy. My role is a geothermal evangelist. I teach here in the department. I taught last year. We had 9 students in the fundamentals of geothermal energy. This year we have 25 students, so we tripled in size in 1 year. I think that's a measure of the interest in geothermal energy right now. I think that right there says enough. We also have visiting scientists from the Bureau who come down and come to our lecture. So it's a, if you look on a hot topic. I also teach at Rice University. I teach the same course at Rice University. And then I advise startups. So I have several startups that I helped move along in the geothermal world. And through that, I get exposed to a lot of employment opportunity, which I think probably is interest in the room. Speaking of which, there's one Sam Claren online who was a student last year. And Sam, I believe, is working in the geothermal industry now. So about a third of the students that I teach go straight from my class into an internship or a job. And the business is booming. So another thing I do is lobby at the state legislature and at the federal legislature. The other element of what I do is R&D. So I'm doing that at the Bureau, applied research. I'm a part-time Bureau employee. We have just started an industrial affiliates program. We had our first meeting in May, I think it was, of last year. We had about 30 companies come. We've had 2 companies sign up already, and we expect a third shortly. We will then be officially started. I can't tell you who those 2 companies are. We normally have a policy of not announcing it until the project's up and running. But they are not traditional geothermal companies, and they are not traditional oil and gas companies necessarily. So I think that also speaks to the interest in geothermal in general, is this broad cross-section of people who are interested in it. So these companies are talking about paying $7,000 a year to gain access to what I'm about to show you. We anticipate going more than 3 for sure. But that is opportunities for scientists to collaborate with us, and we're looking for people in the same building should be collaborating. Students. We expect student projects to come out of this, postdoc projects, and so on. So we had this meeting in May, and so the material I'm going to present to you comes from that. This really goes to the motivation. Traditional geothermal is still out there. It's mature, but there are advancements taking place now at the cutting edge of geothermal that is making it more broadly applicable. We call that geothermal anywhere, and that's really the impetus for the growth in that. The growth is not in the traditional particle of geothermal; it's in this new geothermal anywhere space. And if you want to think about it in oil and gas terms, the analogy that I use is that traditional geothermal is like traditional oil and gas, vertical wells, even deep water wells, drilled, maybe deviated, but not fracked, not the horizontal drilling, not the shale drilling. Geothermal anywhere is shale drilling equivalent for geothermal. And I suspect it will overtake the whole traditional geothermal world very rapidly. And so that's where we're focusing on. New advancement is drilling, engineering, stimulation, and so on, that come from the shale world are being applied in the geothermal world. There's this sort of political pressure of decarbonization requirements, ESG, etc. And then there's advances in the conversion of that heat into electricity. This cutting edge that's happening that is really driving the interest in harvesting heat and producing energy. So you may have seen some of these people all walking around the hallways in the building. This is the group of the hot rock people. Ken Wizian is our fearless leader. Ken is the associate director, assistant director, something like that of the Bureau. Top guy in the Bureau. He's a geothermal guy from way back. There are several scientists you'll recognize here. Nicola Tasato from the department is involved doing experimental work. And then, so we're about a staff of what, 8 or 9. And this is the core group, but this is what we need to supplement because we can't cover the broad space of scope that we desire to cover. We need capability to evaluate what the resources are. We need capabilities to get at those things in the subsurface. We need high temperature subsurface capability to measure what's in the subsurface. We need, once we get it to the surface, we need to know what our options are to use that heat for direct use or in power generation. All of it needs to make techno-economic sense, and it must comply with policy. So we need experts in that space. And then there is this application of new sort of big data and machine learning applied to this. That is a very intriguing space that is just starting to come into use, and we'd like to exploit that as well. So, and that's probably 50% of what we need. We just don't know what we don't know. The Bureau has some existing research programs here. This is a list. And for almost any of these, if you enumerated with me, I can tell you how they're connected to geothermal. And so we anticipate some collaborations with existing IAs. We will focus, in fact, on this collaboration, and we would like to have that level of collaboration with UTIG. In new geophysical techniques for sensing heat in the subsurface, or the location of hot water flowing systems, and etc. There's lots of opportunity space here. So the Bureau actually has been involved in geothermal energy for quite a while. They were leaders in the Pleasant Bayou test wells drilled in Houston in 1979, where they produced geothermal energy and natural gas that was entrained in that water for a year. And in the 1979 technology, it was economic. Nowadays, it would be super, okay? But it was very tied to the price of oil. And in the 70s, when they were building this out, that was the energy crisis, and lines of cars at gasoline stations. And many of you don't know anything about that, but I lived through that, and it was traumatic. And so there was a big boost in geothermal research. And by 1979, the price of oil had dropped, and the lines were gone, and it was boom times in the oil fields again, and people lost interest in geothermal. So geothermal has been anti-cyclical to oil and gas for the most part. I think this is what's happening now is different. Geothermal is booming, and I will talk a little bit about some of the money that's flowing into geothermal, while the oil price is, West Texas Intermediate is at $90. There is now things are getting out of phase, and I would like to think that we are in for a boom kind of exponential growth in geothermal without the lulls driven by the connection to oil and gas. In fact, some of that is being driven by oil and gas. So when you hear about some of the companies that have joined, they're traditional oil and gas companies, some of them, and they see geothermal as a way to get some of the ESG credit that they need. They also have capabilities, people, data that will enable geothermal and money, by the way, I should say data and money, to scale geothermal widely. A lot of this is driven by the boom in Texas, if we want to get specific, was driven by this report from last fall, called The Future of Geothermal Energy in Texas. It's about 400 pages that lays out what the opportunity space is like in geothermal in Texas. So if you're interested in doing geothermal in Texas, I highly encourage you to look at this report. And by the way, I'll make the slides available to Michaela and she can distribute them so you can get to the link here. But in it are 14 chapters. I've listed the chapters here for you. Everything from the energy production, direct use, drilling, the oil and gas engagement in geothermal, et cetera, et cetera. And I'll just point out that 8 of the 14 chapters were co-authored by members of our core team. So we were intimately involved in the production of this report, and this report is starting to drive geothermal energy projects in Texas. There's about to be one announced nearby here that is at a Defense Department site, which I can't talk about yet. So, but that has driven this development of the Texas Geothermal Energy Alliance. This is a lobbying and education trade association of which I'm on the board. And we took that report to the legislature, which was just in session, and we put forward 5 bills that we wanted the legislature to act on that were going to make doing geothermal in Texas much simpler and much more possible. And I'm happy to report that, those are everyone who joined, and you can see traditional oil and gas people there like Weatherford and Chevron and Chesapeake, but non-traditional people like Centerpoint Energy. They're the people you buy electricity from in Houston, for example. Helmerich and Payne is a drilling company. Repsol is oil and gas. And then there's some startups in there like Fervo Energy. And so there are a lot of people who are interested in moving geothermal forward in Texas. And I'm proud to say that all 5 of our bills passed. I think that speaks to the bipartisan interest in geothermal energy. In fact, of the total vote for all 5 bills was something like 600 to 4. So we got 4 negative votes in 5 bills. Okay, that's near unanimous as you can get in the legislature. And there were things like defining who owns heat, because in Texas it wasn't clear. You produced heat from the subsurface. Is it a subsurface right or is it a surface right? Well, it turns out, as of September 1st, the surface right, the heat is owned by the surface owner, which is a little different in oil and gas. We consolidated the jurisdiction under the Railroad Commission. Prior to September 1st, there were 5 agencies, all who said you need to come to us to do a geothermal project. Now it's the Railroad Commission, period. And they very quick in doing permitting. For oil and gas, we like to think they'll be equally quick for doing geothermal permitting. Another law in Texas was that if you wanted to sell an abandoned or orphaned oil and gas well, you had to sell it to another oil and gas company, period. So we changed that law. Now geothermal companies can buy orphaned oil and gas wells and convert them to geothermal wells. That's a big opportunity space in Texas. Another interesting thing was that geothermal, by definition in the state legislature, geothermal is not a renewable energy. And there's technical reasons why that may or may not be, but the reason that the legislature defined it that way is that you may recall the legislature came down on renewable energy sources this past session. They were cutting subsidies, they were blaming them for the freeze and you know, the blackouts, probably not true, but they were the scapegoat. And what we feared was that we'd get tarred with that same brush. That geothermal would be called renewable, and we wouldn't get any economic incentives. So technically, by definition, geothermal is not a renewable energy in Texas, but that was just so that we could get to the gap. And then lastly, we positioned ourselves with ERCOT, the energy managers of Texas, to allow geothermal to be a power provider to the grid. That's just a sort of inside baseball thing that had to happen. There's a whole list of things. I'm not going to read these to you. I encourage you to look at these when you get the slide deck. But these are the kinds of questions that we're trying to address. And I know the group of 9 that we have so far do not have all the capabilities needed to do this. And I hope that some of that capabilities are in this building or at this part of the building and in this room. So what we did was we presented about 20 or 30 ideas to the 30 companies that were assembled here for our pitch. And we said, we're not going to do all of these, but here's the kinds of things that we want to do. And so I've selected a handful of them just to give you a flavor for the kinds of research projects that we're pitching to the consortium. And then the consortium in the end is going to say, we like these and don't like those. Okay. So one of them is around direct air capture and the connection between direct air capture of CO2 and geothermal. A lot of economic analysis going in here. And across the top, you see the cost of capturing a ton of CO2 with a couple of different technologies. First is in red, if you just use electricity. The dark blue is a new geothermal well, and the light blue is an existing geothermal well. And so what you can see here is that in the Gulf Coast, that's the cheapest between Gulf Coast, Los Angeles, Alaska, and the Netherlands. The cheapest place to capture direct CO2 directly, geothermally, or for that matter, with electricity, is the Gulf Coast of Texas. But if you look at the carbon intensity of that capture, you'll see that, in fact, the Los Angeles basin is the least carbon intense. What's carbon intensity? It's the amount of carbon you create capturing the carbon that you're trying to store. So in Texas, using the Texas grid, or I'm sorry, using that's geothermal. This is a full life cycle analysis. 42% of the carbon that you think you're capturing and storing, you're actually sort of re-emitting in the capture process. And in fact, the Los Angeles basin turns out to be only 22% intense. So 78% of the carbon you're capturing is actually getting captured. Yeah.
Why?
Why? Yeah.
Why is Los Angeles so much better?
Yeah. I think it has to do with the transportation distance and the connection to local manufacturing. But I didn't do the report. I'm just reporting on someone else's work. The interesting piece that I didn't show you here is comparing different energy sources. So this is all electricity versus geothermal. But overall, if you do electricity versus natural gas versus geothermal, if you use electricity, your carbon intensity in Texas is 90%. So if you just use a Texas grid and capture direct air capture, you're creating 90% of what you capture, more than 90%. You might as well not do it, right? In fact, natural gas is, I think it was 60% intensity, and geothermal, as it says here, 42% intensity in Texas. So this is the kind of real world techno-economic analysis that we need to grind through to decide which one of these technologies is appropriate for direct air capture. Another thing we're doing is a quality assurance on the US heat flow database. When I was a student here, my advisor was a guy named John Slater. I don't know if you've ever heard of John. He was associate director at UTIG, and he was Dr. Heat Flow. We got, as his student, we got a real intense, briefing on heat flow. I'm back to it now. It's sort of one of those circles of life kind of things. But what we're doing is essentially converting the US heat flow database into an international standard, so that we can then start comparing apples to apples projects in the US versus project in Europe. And it has a lot to do with the corrections that you apply, because often the bottom hole temperature is reported right after you drill the well. And the problem is the circulating mud has dropped the temperature of the rocks. And you need to basically let that well equilibrate for a month or more to get back to that true temperature. And if you're a driller, you don't want to sit on that well for a month. You need to move on, right? So what's done by standard is a correction. The problem is different companies have different policies. Someone might wait a week and then make the measurement. Well, that makes a big difference. Even just a week, there'll be a lot of equilibration that goes on. So it's a very complicated process to get this data into good shape. And this, for example, is a county by county analysis. This is Bexar County near San Antonio. And what you'll see is a lot of data up shallow and only one data point deep. And there's a lot of noise in determining what the temperature gradient is there. And in fact, it only covers the southern half of that county. That's the data. So we need to go find more data, and we need to make that error bars on those gradient maps much tighter. So that's the focus of what we're doing. We've also done site characterization. So Ellington Field in just outside San Antonio, outside of Houston, where the NASA pilots land, and they interact a lot with NASA, is an Air Force base that wants to go fully geothermal. So they hired Sage Geosystems to do a project there. And the Bureau was basically the consulting geologist. They helped prepare maps. They did a bunch of nearby data analysis, and they used the scissor network, the seismic network, to examine the induced seismicity. So they recorded data for several months before the project. Then they did this project, and they wanted to see if there was any induced seismicity. So that should be in the wheelhouse here at UTIG, right? But I can imagine projects like this going on all over Texas, and each one of them being student master's thesis, for example. Another project we're working on is using our techno-economic capability to automate the analysis of the geothermal potential under a set of fixed point locations. And first we're going to do is coal plants. So we're going to go to every coal plant in the United States, calculate what the geothermal opportunity is there, and rank it. Then go to the people who own that plant and say, hey, you're sitting on a geothermal gold mine here, why don't you shut down your geothermal? The thing, you laugh, but over a third of the coal plants in the United States are closing in the next 2 years. Okay. So they're looking for a way out. And the people who live in that area are looking for jobs. This is a way to continue the jobs. It's also a brownfield site. It's already industrial and dirty. You don't have to worry about destroying a green field to do a geothermal site.
Is there any reason why coal plants would be built on top of geothermal areas?
Our coal plants geothermal is being put under where there are coal plants, so that the coal plants can shut down and we can tie into the grid using the same grid connection that the coal plant did.
So is there a reason why coal plants would be built in places where that's viable?
They're not. A lot of them are not. That's why we're doing this exercise to do a ranking of which ones are viable. And then we can take that data set and go, okay, let's look at cities. Let's look at nuclear plants. Let's look at, Australia and look at coal plants. Once we build this automated technology for doing this, we can apply it everywhere. Saw a hand go up somewhere.
Yeah, I have kind of a related question. That's very basic, but I think of geothermal heat flow as like coming through the surface of the rock, and clearly you're talking about a lot of the heat that is stored in deeper layers. Is that, and so I mean, my first question is the heat flux coming through the surface, is that a good proxy for the potential at depth? And if not, is that because of the presence of fluid? Is that because of different lithologies? Like, why is it that there's all this potential deep down that we might not recognize at the surface?
Right. So there's a half-an-hour presentation that would answer all of that I didn't do because I only had half an hour.
Fair, totally fair.
But to answer your question, the heat flow coming up to the surface is less than the solar irradiance coming from the sun.
Right.
So we don't generate.
Yeah.
Energy at the surface, we gotta go deep.
Right.
Now, is it a good proxy? Absolutely. And not as good as having a subsurface sample, but you know, if all you can do is get heat flow from the surface, then yeah, okay. And the reason is that 60% of the heat is radiogenic heat. So if you're on a granite batholith, the heat flow is higher than if you're in a deep sedimentary basin. Right, so there's variability there that you just, it's gonna have some uncertainty, but you got nothing else. Heat flow is, and if you look at a lot of maps of the United States, they're talking about heat flow from at the surface. Yeah, so if you're interested in laboratory work, this is work being done by Nicola Tisato in laboratory measurements of rock related to determining properties that affect it if you are using geothermal. In this case, it's fractured rock. It's what's called enhanced geothermal. This one is one that I proposed. This is the idea of using salt domes as your target. Why would you use salt domes? Well, number one, the salt domes have 3 to 5 times the thermal conductivity of rock. So, and then the second thing is they go down 5 to 10 kilometers deep. So each one of these is a heat pipe, of a chimney of heat. And so what if we were to drill into these with a closed loop geothermal system and produce, right? So that's one of the projects we're proposing. If we can get money, we're gonna go drill, I hope, into Spindletop, which is the place where oil and gas was first developed in Texas. I love the symbology of drilling into that dome in particular. But anyways, that's another project we've proposed. Here's another one. I'm gonna wrap up now. Stimple is about using the prospectivity of the Smackover for lithium brine. So getting brine, the lithium out of the brine to make batteries. The brine in the brine associated with Smackover is over 600 parts per million. The brine in the Salton Sea, where everyone is hailing, this is going to change the lithium landscape for North America. We're not going to have to rely, blah blah blah. 400 parts per million. The Smackover is a third better than that. Okay, so we need to go characterize where are the hot spots and so on. And then the last one is using the Advanced Energy Consortium, is an oil and gas supported group at the Bureau doing microsensors. And you can see here in the middle, that's what a nickel, and the sensors are a tenth the size or less of a nickel. We're talking about dropping these sensors into geothermal wells, measuring pressure, temperature, etc. Right now they're suitable for oil and gas, so temperatures below 150 C, we need to get much hotter. So if you're interested in microelectronics and all of that, we got people working on microsensors as well.
What was the temperature?
So the 150 is the normal operating peak temperature for off-the-shelf oil and gas stuff, including these sensors. But 150 is essentially the floor of opportunity for geothermal. So
Fahrenheit?
was that
Celsius?
Celsius? Yes, sorry, because I work for Shell, I think in Celsius, meters and all that. Okay, question, yes?
Yeah, but so thank you very much. It's good to know that we have a good geothermal group, first of all. But I totally agree with you that the image SEG conferences, they're a good gauge of knowing where the market is going. So in 2016, I had colleagues in Chevron and Exxon, and they said, okay, we will go to geothermal if necessary, but probably not. And now, image conference last week, you saw that completely, but there was a lot of geothermal kind of.
Yeah, I taught a short course with almost 30 oil and gas geoscientists learning geothermal.
This time?
This time.
Okay, but you were there showing that the focus kind of pivot to natural hydrogen.
Yeah.
And CPRO minerals and CCS. Okay. Now, what you're saying, it's good, but when we discussion with those people that they're pivoting because of climate change, they certainly will not go to geothermal. And you're right, Iceland, 95% of their energy, they're circulating to 1.5 kilometers using geothermal, some for heating houses and some for energy. And we go and we do monitoring with my colleagues in Germany to electromagnetic monitor the reservoir. But in Hawaii, they had a plant, the Big Island, which is 10-fold the valuability or the production. At the end, the community shut it down. The Navy in Kaneohe approached me to map their geothermal because the Navy is the entire base sitting under. And eventually they didn't get the community approval. So I don't see where geothermal would fit into the scope within the transition to renewable. I think it's a great thing to study as a scientist, but I don't see what can you comment on that? Like as an energy resource. I think we're gonna skip the laser disc.
I like that. There's a reason for the resistance in Hawaii that's too long. I don't want to take away from Sarah's time. But I think there is plenty of opportunity here. And for example, in Europe, Germany in particular, there's heat networks that the cities run on that heat their homes. And they're trying to get off Russian natural gas to heat that water. Coal is another opportunity they don't want to use, and nuclear they are shutting down. So what is your opportunity to heat those millions of homes in Europe? You only have one, really one. That's going to be geothermal, and that's going to require geoscientists and geophysicists and so on. I don't think it's possible to deny that there's an opportunity space there. So I'll tell you the Hawaii story.
Yeah.
Got a really quick question. You may or may not know the answer to this, but do you know if there's any planetary applications people are looking at?
Absolutely, and Ken Witzian, my partner in all of this, that's his focus actually, is interplanetary geothermal. Yes, they're particularly looking to geothermal for energy on the moon.
Okay.
For example, because it's all about delta T.
Okay.
And so maybe the temperatures are cold, but as long as you're 100 degrees different, you can generate power. And so yes, it's a big focus, and a lot of the interplanetary probes run on delta T. Nuclear fission reaction, and the cold side is space. So there is lots of principles that go along.
Please don't hesitate to reach out to Malcolm to ask more questions. I've learned a lot. I hope y'all learned a lot too. So let's thank him really quick. Cool. And so for the second half of this talk, we'll be listening from Sara. If you haven't met Sara already. Sara Sieberath, everyone. Quick introduction. She's the assistant director here at UTIG. So if you ever need anything, I always hit up Sara. But she has a bachelor's in biology and a master's of education at UTIG and 17 years of experience in higher education administration. She knows what she's doing with a focus on research administration. So everyone should be paying attention. Sara has extensive experience with the NSF, NASA, and Department of Energy grants and Department of Defense contracts. And she has been the administrative lead for over 140 proposals since joining UTIG in 2016. So I did the math, and that's like 20 per year.
And I told them when I came here that I was not coming here to do proposals.
And let's welcome Sara.
Yeah. So this will be short and not very in-depth, but I wanted to give you an idea of what it looks like to propose for funding. As she said, I'm mostly experienced with NASA, NSF, and Department of Energy. And I came from Applied Research Labs, which is across the Pickle campus, and we did only contracting there. So a lot of people get stuck in the world of grants because that's maybe what your supervisor does. But there's a lot of opportunity out there in the contracts world. And I think BEG in particular does more contracting work. And UTIG usually does more grants work. So the very first thing you need to know is when you get funded, what are your responsibilities? So this is just a quick overview, and we're going to start with roles and responsibilities. We're going to talk about finding funding and then the proposal process. And again, this is all going to be very abbreviated. So as the project lead, you're responsible for everything that happens on the project pretty much. So that means you manage people, you manage things, resources, you manage your labs potentially. Lucky for the people at UTIG, you have a fantastic administrative staff to help guide you through all of this stuff. So we have a great HR staff. We have great purchasing that can help you procure any of the stuff that you need. And we have great technical support, people who really know what they're doing and can help you with lab work, with data work. any of that kind of stuff. But ultimately, if you get funded and your name is on the project as a PI, it's your responsibility. One thing that I did want to point out is managing compliance. The first thing that you have to do when you get PI status is go through a 9-page document that is about integrity and research, integrity, lab safety, all of the things that institutionally UT wants you to be responsible for and wants to make sure you understand that you're responsible for. From the funder's perspective, you're also responsible for all the reporting to them. This is just a quick chart, and I made it bigger in your handout so that you can actually read it. That is delineating between the principal investigator's responsibility when doing proposals, the departmental research administrator's responsibility, which is me and my team, and the central office OSP's responsibilities. OSP is here for compliance reasons. That's what they're doing when they look at your proposal. We, as departmental research administrators, are here to also help you with the composition and the quality of your proposal. So if wherever you go, find a research administrator. If you don't have one assigned to you, find one anyway. If you can't find one, call me. We have somebody who went to Scripps 2 or 3 years ago, and I helped him through something that he wasn't understanding because his research administrator wasn't able to explain it to him in a way that he could understand. So we worked through it together, even though he's been gone for 2 years. So we are worth our weight in gold here. So finding funding. To lead or not to lead, I've got 2 slides on this. There are 2 things to consider. Are you going to be the lead institution if you're collaborating, and are you going to be the lead at your institution? So this slide is just talking about some of the things to consider. If you are the lead, you take on all of the responsibility. If you're not the lead, you contribute more, but the lead is responsible for finishing all the reporting and really managing finances from a high level of the project. I would not recommend leading early on when you're first starting to do research proposals. If you're doing like a fellowship or something, that's a different story. But when you get into managing personnel, having a lot of moving parts, it's really good to collaborate with people who have more experience than you. And for leading internally, there are other departments that you might work with, and they might lead. Basically, the point of this slide is that UT is UT to the sponsors. They don't care about our internal structure. So they will not care that DGS has a completely different support staff and structure than UTIG. So it's just something to keep in mind when you're collaborating with people internally, is that you might need to work with their internal structure and their processes, even though you're used to working with ours, for instance. And the sponsor doesn't care. They see, again, UT is UT. If you are collaborating with another organization on campus, if you were the lead, we want a proposal from them separately for their part, so that we can say, this is what UTIG is doing, and this is what DGS or EPS is doing. We want to be able to delineate that so that we can help you if you get into a bind where it's not clear who's responsible for what. That's why we ask you for a proposal up front from the collaborating department, so that it's very clear who's responsible for what. So the university subscribes to a platform called Pivot, and that address at the top is the university's portal into it. You use your EID, and it is the thing to find funding. And I've listed on here a lot of different kinds of funding that you may not be thinking about. Especially early career, you may be thinking there are fellowships out there and there are grants, but there's a lot of other opportunities for you to get funded. Even if it's just getting travel support to go to a conference, for instance. I also found on University of Nevada, Reno, they have a really great site for listing a bunch of early career opportunities. And I pulled out these 4 areas that might be of interest. Their website actually has a little blurb for each one, so I would definitely recommend reviewing that. And now to the proposal. So the very first thing you're going to do is find what you're going to propose to, and then you're going to read the solicitation. And as soon as you decide that you're going to propose, we, the departmental research administrators, want to know. And the thing we want to know is, when is it due and what is the solicitation? Because the very first thing that we're going to do is try and figure out how to fit you into our queue so that we can give you the support that you need. And we want to help guide you through the solicitation so that we can point out things like, you don't need to worry about whether you've got 1-inch margins, because we're going to check that. So you don't need to worry that your font size is too big or too small. We're going to check that at some point and let you know. So you need to focus on the science, and we prefer that you be responsive to us, but we try to be very careful about that by telling you up front, here's a checklist of the things we're going to need from you. And we try not to bug you until time is getting critical, because we know that you are working on the science part and we can't help you much with that. Yeah.
If a call requires like a letter of intent or pre-proposal, is that something you want to know about, or is it?
We do want to know about it, and here's the reason. If it doesn't require an institutional signature, you don't have to come through us. But we have an internal database that we use to report to the director what your activity has been. And it will help you, because research staff here have to do an annual activity report, and we provide that back to you. So you can see all of the details without having to go fish for it. The pre-proposals are not that common, but on those, make sure that you're watching dates. They're very important. So for personnel considerations, I just wanted to point out that just because somebody is named in the proposal doesn't make them key personnel. They have to be named as key personnel. So if you name your postdoc, the postdoc could potentially go in 2 places. The postdoc could go as a postdoc, just a regular postdoc, or the postdoc can be responsible for a significant part of the science in a way that they're going to get co-PI status. Once they have co-PI status and are listed as a co-PI on that proposal, then they are key personnel. So you can't just switch them out once you've told the sponsor that that person is working on it. If they were a postdoc, then say they get a different job somewhere and they're ready to move on, you can hire a different postdoc to fill that role. If they're a PI, if they're a co-PI, then they may want to take part of the project with them, in which case we could potentially subcontract or subaward out to them. So especially at the postdoc level, if you're going to propose something, talk to us about it, about how is the best way to do it. And in particular, we have strategies for, we know postdocs, at the Jackson School, they don't allow postdocs to be more than 3 years. So if we were putting you in a 5-year budget, then at the 3-year mark, we're going to switch you over. And we're just going to explain why we switched you over into a research associate role instead of postdoc role. And that way we can build in enough money so that you're not kind of biting yourself by not building in for the significant pay raise that happens between the point that you're leaving a postdoc and going into a research associate's role. Also, awards are issued to the institution, not to the PI. So you can't take an award with you when you change institutions unless the institution agrees to it. I have not seen UT have a problem at all with transferring stuff. You just need to make sure that your collaborating PIs and co-PIs are on board with the plan. This is the process, and I'm not going to go through every point. What I wanted to show you is the left in blue is the PI's responsibility and the right in purple is our responsibility. So we are doing a lot of work for you, and that's why we want you keeping us up to date on what's going on, communicating with us, letting us help you. So that was just the first part. This is the second part. And this is, by the time you get to this stage, we need 2 weeks from the time you think you're done until we're ready to submit. A lot of the times we can be flexible and we can let you keep writing the science part while we're finishing up the other part and working with OSP to get things done. But it does take a lot of time, especially in the summer when people are absent, because everything that goes out of the UTIG gets read by Damien. So if he's out of town, we need to make sure that we've got a draft ready for him to read when he's on a plane and has some time to read it, right? So we will work with you on those schedule issues. Okay, so here at UTIG, the official process gets started by you filling out a form. And back to what I said is the most important things that we need to start with is what is the due date? When do we have to submit by, and what's the solicitation? Everything else on the form, you can change later. We just want to get a good start, get you in our queue. So if your title changes 30 minutes before we're going to submit, that's okay. It happens. And usually when that happens, it's because you guys decided 5 days ago with your collaborators that the title was changing and forgot to tell us. So back to communicating with us is really important. These are all the things that are on our list. Very few of it is a mandatory field. The proposal components. So mostly the things that you're going to be working on is the summary or abstract and the project description. But notice there's all this other stuff. And by other, as required by the sponsor, that can get extensive. So you can have appendices that are required that maybe we can prep for you. Or if it's a contract, a lot of times the federal government is required to vet out the costs that we propose. So they'll have specific forms that they want filled out with salary rates and fringe rates and facilities and administration rates. And we can do a lot of that for you. The things in particular to watch for are mandatory templates, all the normal formatting stuff. And usually they don't allow you to put links, and we will watch for that for you guys and point it out if you've got a link in there. What they're trying to avoid is people skirting page limits by linking to things that are relevant to the project. And then the budget requirements, there will be budget guidance, and we can help you navigate that. It will sometimes say, for instance, NSF, if you're faculty, you're not allowed to have more than 2 months of NSF support across all projects in any year if you're faculty. They do that because the assumption is that faculty is not charging projects, not that they're not working on projects, but they're not charging projects during the academic year because research is part of their job as a faculty member. So they limit it to 2, assuming that you're only charging the grant during the summer. But if you are at UTIG and you're a research scientist, we have a little statement that we put in the budget justification to tell them, hey, our model is different. We need you to let them propose for more than that. And we've never had a problem with them saying, no, you can't exceed the 2 months when we make the argument that you're not faculty. Cost share is its own monster. The only thing that we really see it required in is Department of Energy. If you're going to do something Department of Energy, see your administrator. So budgeting is kind of the last thing that I wanted to look at. I think you guys have probably a pretty good idea that whatever you need to do the research, you're going to have to get them to pay for. The thing that I want to point out on here that people tend to not think about and tend to get shocked by when they first see it is the overhead rates or the UT facilities and administration rates. So basically, your salary, if you are making $10,000 a month, your salary is going to have 30-ish% added onto it for the fringe benefits, and then another almost 60% added. So you're almost tripling. It's kind of a big deal. So facilities and administrative costs are meant to cover all of the things that are not directly, that you can't draw a direct line from to the research project itself. So for instance, people like to use the electricity in the building or the janitorial service in the building. We can't say the janitorial service spent 2 hours of their time every month working in your lab. We're not going to do that. We can say you spent 2 hours of time really 20 hours of time every day, maybe. Working in your lab. So we can draw a direct line from what the time you're putting in to what we're charging. The things that we can't draw that direct line is considered overhead, indirect costs, UTF&A. Those are the three things that it can be called. And again, that tends to be a shocker on your price tag. So letting us know upfront what you're planning to budget, we can help you remember, okay, if you're going for travel, maybe you need to put in airport parking. Maybe you didn't think about that. Or maybe you need to put in registration costs because, for instance, AGU, it's not inexpensive. So the good thing is when you're looking at grants for NSF and NASA in particular, they tend to be fine with funding those kinds of things, funding travel for AGU and other professional development opportunities like that. So we're almost at 3 o'clock. I can click on through. There are good news that some things are exempt from F&A, but most of the things that are exempt are not things you're going to be worrying about in your early on proposals. So just remember, research is expensive. And this is just pointing out that when every proposal requires a budget justification where you're justifying your costs, that's not justifying the need for that cost for the research. So you don't need to justify that you need to put time into the project. You need to explain what you're going to be doing, like how much time you're going to put in and why you need that much time, not literally what you're doing, because your project description should be describing what you're going to be doing. And then say you need you're going to do sample analysis and you're planning for 50 samples that you're going to run 5 times. That's the kind of detail that you would explain in a budget justification. You would explain in the project description what kind of samples you're going to be running and what kind of analysis you're going to be doing on them. So And the submission is just back to this long guy, reminding you time is important. And when you collaborate, especially with other institutions, with people that you can't just go knock on their door and say, hey, where's this section? I need this section. Things will lag and you might not get it done. So be very, very mindful of your timelines. And that's a lot crammed into 20 minutes. So if you've got questions, you're welcome to ask me now. I can stay a few extra minutes. Also, my office is over there. I'm happy to have walk-ins, and some of the researchers here who have been here a while will tell you that just coming and talking through things with us is really helpful.
Any immediate questions? I think it's really interesting that, you know, we saw this like multi-institution project for Malcolm and saying like all the logistics, and then hearing like all the behind scenes from like the admin staff about like all the work that needs to go into it. So I hope you all learned as much as I did, and thank you both very much. So if no questions, thank you. Thank you very much.
Yeah.
So
Wait, I'm kind of. Borrow the